this 3 into the original equation, you're going to get 0 in the bottom of the fraction. Right? So you could toss that 3 immediately. Right? But you could also go the route of checking your work, or checking their work step by step. So what they did, they ignored the part where they would find the bad numbers. So maybe we do that off on the side, just so we have the appropriate work. We would say, you could just make a little note here, bad. X squared minus 9 equals 0. X minus 3 equals 0. X squared minus 9 is a difference of perfect squares, and its factors are what? X minus 3 and X plus 3. That line is showing up in the math. Okay. All right, then when you set each of those factors equal to 0, you get X minus 3 equals 0. X plus 3 equals 0. You get X equals 3, X equals negative 3. All right, the X minus 3 equals 0 doesn't bring anything new to the party, so you can ignore that. It's the same equation that we have over here. All right, so we know that this guy is no good. All right, now when they cross multiply, it should be 3 multiplied by the X minus 3. That seems to have happened. They should also have multiplied the X squared minus 9 by the 1. That also seems to have happened. Then in the next step, it seems like they're subtracting the 3x and adding the 9 to both sides. All right, so it would cancel on the right. That's good. On the left, it looks like the 9s would cancel. So this is the correct step. Looks like they factored out a GCF of x. I don't see anything wrong with that. Set each factor equal to 0. Don't see anything wrong with that. It looks like literally the only thing that they did wrong was that they did not account for the bad possible values of x. All right, so it's kind of like working bottom to top as opposed to top to bottom. All right, so that's something. Let's see. They showed me this yesterday. It sometimes works. This is apparently not the time that it's going to work. Let's do it this way. Okay, so the word problems. Word problems are nothing new. And really none of the word problems that we've done all year are anything beyond stuff that you've seen before. We're talking about perimeters, we're talking about areas, talking about maybe money, for cost or something like that, but nothing that's, out of your wheelhouse. All right, so we have the length of a rectangle is 5 inches more than twice the number. All right, the width is 4 inches less than that same number. All right, so define our variables. And defining your variables can be simple. All right, twice a number. All right, so that'll be our x. So that's the same x, then the same number, so the same x. All right, so the length of the rectangle is 5 inches more than twice the number, so length. 5 more than 2x, so 5 plus 2x. The width is 4 less than that number. So that's going to be x minus 4. All right, so we have our 2 dimensions. Perimeter is 44 inches. Sketch a diagram and find the unknown number. Okay. So perimeter, 44. Length, 5 plus 2x. Width, x minus 4. Perimeter of a rectangle is 2L plus 2W. So we pop our known information into this. All right, so 44 equals 2 times 5 plus 2x plus 2 times x minus 4. Distribute, simplify, and solve. So run through with the 2. So 44 is going to be equal to 10 plus 4x plus 2x minus 8. Combine our like terms. We have 44 is going to be equal to 6x plus 2. All right, so we just have to subtract and divide. So knock off the 2. We have 42 is equal to 6x. And if I divide both sides by 6, I'm going to get a 7. All right, all they're asking us to do is find the unknown number.
Would it be 6x minus 2?
6x minus 2? Could be.
Because it's 10 minus 8.
10 minus 8 should be a positive 2. All right, and so we have our unknown number. That's all they're asking us for here, which is good because we didn't have to worry about units or anything like that. Now they're telling us if the area is 15 square inches. All right, they didn't ask us to draw a diagram, but yeah, I'm going to do it anyway. Poor quality, of course. I'm not going to put too much effort into this, into drawing anyway. Put the x minus 4 on this side. All right, so area is length times width. So 15 is equal to 5 plus 2x times x minus 4. All right, so we'll have to distribute. All right, but we have to double distribute. Right? As I was walking around yesterday between the two classes, I noticed that people were just forgetting how to double distribute. Right? When you're multiplying two binomials, you got to multiply each part of the first binomial by each part of the second. So 5 goes to each term of the second binomial, and so does the 2x. All right, so we're looking at 15 is equal to 5x minus 20 plus 2x squared minus 8x. Now, the big question that came up yesterday was, especially comparing part A and part B, was, well, how did I know I didn't have to factor there in part A, but I'm about to tell you that you need to factor in order to solve in part B. How do I know that we're supposed to factor? And the answer has to do with that little exponent. Right? If there's a power of 2, that makes it quadratic. If it's quadratic, that means that you need to factor in order to solve. Right? So that's telling us to get everything over to the same side. So in part A, there was no power of 2, so our job was to isolate x. Now our job is to get everything over on the same side and factor in order to solve. All right, now, I don't know where you're all going to end up next year. I'm going to do my spiel for course selection either tomorrow or Friday, but like the rationale behind why you do what you do, that's at this point, I mean, you want to just get stuff right, that's a standard level way of doing things. If you want to understand why things work the way they do, that's an honors level of doing things. If you just want to do more, that's a gap way of doing things. All right, so in this case, what we're trying to do is write our quadratic function. So this is honors thinking. Right? We want to write our quadratic function as a product of linear factors. The reason why is because we spent more than a marking period learning how to solve linear equations. All right, part A is linear equations. Pretty easy to do. If we can take a higher order function, something that's got a power or up to or higher, and make it so that it's a product of first degree factors, so make it a product of linear factors, then we could solve it using techniques that we're already comfortable with. All right. So if you kind of internalize that concept and think about, all right, well that I can do that for lots of things now. Right. The only objective I have is to make it linear, make it first degree, make it a power of one. That opens up a lot of doorways. All right. If that holds no interest for you conceptually, and you just want to say, okay, wait, a power of two, I do this, good, all right, standard next year, all right. So just food for thought. Anyway, I have 2x squared, and of course there's a grade component involved in all that, but I'll talk more about that tomorrow, probably. 5x, I'm going to combine my like terms. 5x minus 8x, negative 3x. All right, negative 20 minus 15 is negative 35. All right. Also, something that you're going to want to start trying to do is moving away from the X chart. There's nothing wrong with the X chart. X chart works. Gets the job done. It does involve a fair few additional steps that maybe you don't want to do. It's up to you. All right. So if you use the X chart, we have a product of negative 70. Let me make sure my calculator is the right calculator. It is. It's just got stuff from yesterday in it. So negative 70. Store at input A. I'm doing very procedural. I'm just looking for a negative 3. So I go up. Did I miss it? Now I'm just double checking something real quick. That's all good. That's good. That's good. Okay. So yeah, it should be negative 70. Oh, okay. I must have typed in negative. I must have typed in 20, or maybe it didn't take because these products aren't negative 70. I'd never hit enter. That's why. Okay. Negative 3, right? Negative 3. There it is. So negative 10 and 7. So we can do it that way. So 0 is equal to 2x squared minus 10x plus 7x minus 35. I'll show you the more intuitive way in a second, because we've had a lot of practice with the X chart, and I think it's time for some of us to try something different. All right, and strategy. We've talked about this a few times. A strategy could be the way to kind of simplify this. And for me, I look at it as like from the left and the right. Don't be so linear. You know, that's the thing. It's like, try to think. You know, they call it outside the box. I think that's too ordinary. You know, like, try to think three-dimensionally. Try to think. You know, don't just limit yourself to left to right, top to bottom. You know, sometimes look at the right side. Sometimes look at the bottom. You know, like that do now problem. Don't work top to bottom. Work bottom to top. You'd be done with the problem in like 10 seconds, right? So in this case, I find it to be much easier to factor out the 7. Maybe you look at it and say, oh, I'll factor out the 2x, but the 7, pulling that out tells me that my factor here should be x minus 5. It reduces the amount of thinking I need to do. Right? And so then I have 2x plus 7 and x minus 5. All right. And then when we solve each of those, I'll just kind of cut to the chase here. We have x is equal to negative 7 over 2 and 5. Now, context is going to be an important thing because the math tells us that the number is negative 7 over 2 and 5, but the context of the problem tells us that we're working with something that's geometric. Well, if something's geometric, yeah, it's possible that the number can be negative. Right? Because it was twice the number added to 5 and all that stuff. If the result, though, giving us the length of the side, if the result is negative, that's not going to work. All right, so if I plug a negative 7 over 2 in for either of these values, will it give me a negative, yes or no? I mean, it was like grumbling more than anything else. I was looking for a yes or no. Like a hearty yes or no. If I plug a negative 7 over 2 in for either of these values, will I get a negative, yes or no? Yes. All right, so we dismiss the negative 7 over 2. Now, it's not, and I can't emphasize this enough, it's not because the 7 over 2 is negative. It's because it leads to a side of the rectangle that is negative. You could already see how this will be a trick question. Right? Multiple choice, trick question. You know, like, which of the following is the number? You know, you plug in a 5. Maybe that's the one that gives you. In fact, I'll tell you right now, if I take this side here and just swap it around, 4 minus x instead of x minus 4. Now 5 is the bad number, right? Because 4 minus 5 is negative 1. All right, so you got to be careful about that. You got to really think this through. The devil is in the details. What's going to happen is, as we move forward, you're going to find, if you're struggling grade-wise, you're going to find that it's not because of the big picture. It's because of the little details. It's always the little details. So let me show you that little, I'll call it a shortcut, but for some of us, it's absolutely the worst way to go. It all has to do with your number sense and whether or not you have it. That sounds like an insult, but it's not intended to be. It's just pull-ups. Never successfully have been able to, in my life, to do a pull-up. Ever. There was a requirement. They had the Presidential Physical Fitness Challenge back when I was in elementary school that required you to do 10 pull-ups. Somehow I passed that without doing any pull-ups. I am unable to do a pull-up. Then the weight got larger, and so now it's like, I mean, if I had a chance to do a pull-up, it would probably be when I was 70 pounds. Now I'm a solid 250, 260 pounds. 70 if I'm being honest. There's no way. There's no way I'm doing a pull-up. All right. So why was I unable to do a pull-up? I never worked at it. Right. That's it's as simple as that. If you don't work at your number sense, you're never gonna have it. Right. So some of us have it because you worked at it. Some of us don't have it because it wasn't even a consideration. All right. So number sense is the key to everything for this approach. What I'm looking for are two values that will multiply to 2x squared. Those are going to go here and here. That's usually the easy part, right? Because it usually only shakes out a few ways, right? So in this case, it has to be 2x and x, or x and 2x, right? Then I'm looking for two numbers that multiply to negative 35. That could shake out a few different ways, all right? Those values are going to go here and here. So this masterful approach I'm about to show you boils down to, all right, well, I'm going to pop in a 5 here and a negative 7 there and see how it goes. And how do we see how it goes? I multiply the outer values. That gives me a positive 10x. The inner values give me a negative 10x. Negative 7x. All right. Add these two numbers together, what do you get? 3x, right? So that's the opposite of what I want. So what do you think I ought to do with these signs? Flip them. All right, so that makes this the negative and this the positive. All right, and so you have your factors. All right, now the big question would be, well, my first thought was 35 and 1. Will that work? Well, no, because the correct factors involve a 7 and a negative 5. So what will happen is you try 2x, let's say plus 35, and x minus 1. You work on your outers, you have a negative 2x, your inners are 35x. The sum of these two values, that's nowhere near negative 3. All right, so you would dismiss this. You wouldn't even consider changing the signs because it's not even going to be close. All right, what's going to happen here is you're going to look at this number here, and you're going to start to realize that when you want a small sum, that these products need to be fairly close to each other. All right, so in order for these products to be close to one another, these two values have to be close to one another. So if those two values are going to be close to one another, and when I'm thinking about the different factors of 35, I would want the ones that are near each other. And I wouldn't want the 35 and 1. I wouldn't even consider that. Right? But if this is large, what that would mean is that these two products have to be far apart in order to give you that big difference. If they're going to be far apart, then these two have to be far apart. All right? But it's the thinking component that makes it all work. Right? This used to actually be the standard way of teaching this. There were entire generations of people that grew up never knowing how to factor because of it. Right? So instead we go with the X chart. You try that, you master that, and if that doesn't work, or if it does work and you're looking for something more convenient, then you go for it's really just called the trial and error approach, but the better name for it is the number sense approach. But because people get offended by everything. They're like, but wait, I have number sense and I don't get it. Well, honestly, rude comment of the day, if you don't get it, it's because you don't have the right kind of number sense. But again, what I'm saying is, I can't do a pull-up. All right, I'm always going to come back to that. All right, if you don't have number sense, my answer to that is, I can't do a pull-up. All right, so what your job is to do is to just tackle the remaining problems between pages 13 and 16. There's not a lot. It goes fairly quickly. But the one thing you have to caution yourself with, like for example on page 13, where it says the ratio. Ratio means fraction. Fraction means that you could have excluded values. You could have bad numbers. So you got to be on the lookout for that sort of thing.